Hi everyone, in this lecture we will be discussing about some common bit operations that we can do using bitwise operators. So let's begin, and let me start with a simple problem. So given n, you want to check if that number is odd or even, right? So clearly you already know one method. If you take modulus with 2 and if this turns out to be 0, in that case n is even, and if this mod is odd, this is 1, then it is odd, right? So let's see how we can solve this problem using uh, bitwise operators. So clearly if we talk about binary representation of a number n, right? So let's say n is 5, and if we look at this binary representation, so it looks something like this, right? So clearly you can tell if a number is odd if the last bit is 1, right? So if the last bit is set or it is 1, then this number is always odd, and the reason is very simple. Given any collection of bits, something like this, you can say except for the last position, all other powers of 2 contribute a even number. So this contributes 2 raised to the power 0, this contributes 2 raised to the power 1, this contributes 2 square, 2 cube, 2 raised to the power 4. So this number is actually 16 plus 4 plus 1, right? So all other powers of 2 are even except for 2 raised to the power 0, which contributes a 1, and this is what makes any given number odd, right? So how do you check if a given number is odd or even? So let's say you have again number 5 and you want to check if it is odd. So simply you can do a AND with 1, and this will be a bitwise and if this turns out to be 1, which means this number is odd, and if this turns out to be 0, which means this number is even. So let us see what happens at the bit level. So 5 is represented like this, lots of zeros followed by 1 0 1. 1 is represented like this, 0 0 0 0 followed by 0 0 1. And if you do an AND, you can clearly see all these bit positions will give 0, even these bit positions will give 0, and finally you may have a 1 here in case of a odd number, and you will have a 0 here in case of a even number, right? So this is how you can check very in a very efficient manner if a number is odd or even. So you can simply do n and 1. If this is the case, then the number is odd. Okay, if this is true, then the number is odd. So let's write a very small function if a number is odd or even. So boolean is odd given a number n, so you can say return true, return n and 1, that's it, right? And you can check for any given number. So let's say cout is odd n, right? Let's build it. Okay, so let us complete all other methods and then we can check, right? Okay, we have to give some return values here. Yeah, so let's see. And you can see we are getting an answer 1, which means we are able to extract the last bit of a number n. So let's come on to the next task. Now we want to do, instead of the last bit, we want to get the ith bit, which means we want to extract some other bit, right? And in this case we would be given a bit position I. So let's not worry about the last bit, let's worry about how to find the ith bit. Okay, so we now want to find out the ith bit. find ith bit, and the position I'm calculating is from the right side, right? So for example, given this number 5, now I'm worried about the second bit, right? Let's say I is 2, so 5 is again like this. So this is my 0th bit, this is my first bit, and this is the second bit, again it is 1. So how do we find out the value at a ith bit, right? So it's very simple. What you can do, you can again create a mask. Okay, so we can create a number like this, and we can do a AND, right? So all these bits will become 0, these will also become 0 because of and finally what you will get will be this bit. Okay, so you will get only this bit, this is the ith bit, and we cannot say this is equal to 1, because when you are going to make some comparison, this whole number will be compared, it will be some power of 2 if this bit is 1. So we can say if this is greater than 0, this whole number is greater than 0, which means it is some power of 2, it means this particular bit is set, or this particular bit was 1. And if this number is equal to 0, right, and in that case we can say this was a 0 bit, this particular bit was 0. So this is how you can get the ith bit. But the question is, how do you create this number, how do you create this mask? Okay, and this is very easy. So what you can do, you can take 1 and you can left shift it by I places. For example, if I do 1 left shift 2, so it will create this number 1 followed by 2 zeros, and that is exactly what we need here, right? So how do you find the ith bit now? You can say, okay, you do n and you do an AND with 1 left shift I, and if this number is greater than 0, then you have set bit. Okay, then you have 1 in that case, otherwise you have 0. Okay, so let's write this code. So let us create a mask which is like this, 1 left shift I, and you do okay, so bit is going to be equal to n and mask, and if this number is greater than 0, then your set bit is going to be 1, otherwise it is going to be 0, and we can say return bit. Okay, so let's say n is 5 and let's say int I, and we do c in I. Okay, and let's see how this goes. C out get bit n and I. Yeah, so here you should it is giving a warning, right? And we should use round brackets so that the expression is evaluated correctly, right? So I'm checking if n and mask is greater than 0. In that case my bit is going to be 1, otherwise it is going to be 0. Okay, so let's build the code and run it. Okay, I say give me the second bit in 5, so it says it is 1. Okay, give me the first bit in 5, it is 0. Give me the fourth bit in 5, it is also 0. So this is how you can extract bit at a particular position. So let's talk about how do we set a particular bit. Okay, so in order to set a particular bit, we will do something like this. Okay, so let's talk about how do we set a particular bit. Set ith bit. Okay, so let's say given a number 5 0 0 1 0 1, we want to set any bit. Okay, let's say I want to set the second bit, although it is already set, but we can still set it, right? We can again say let's make it 1. So in that case, if I have a number like this in which I have 0 at all places and I have 1 at this place, I can perform a OR operation, right? A bitwise OR, right? So if I do this thing, then my original number in this case will remain unchanged because the bit was already set. Okay, so again we will create a mask like this. So mask is going to be 1 left shift I, and mask is again a number, and we can do an OR with the original number. We can say okay and followed by OR with the mask. So in this case, if let's say n is 5 and we want to set this particular bit, okay, in this case I is 1, so 0 1 2, and I will create a mask like this, 1 left shift 1, which is this, and I can do a OR, right? So this makes the number as 7, and let's write it in the code also. So in this case also I will have a mask which is 1 left shift I, and I can say okay, my answer in this case would be number. Okay, so I'm accepting this number by reference, and I can simply say let's update n equals to set that bit, or you can also accept this number by value and you can say okay, I'm going to return the updated value. So you can say answer equals to set the bit, so number, you do a OR with the mask. So if that particular bit was 0, it is going to be 1. If that particular bit was 1, it is going to remain 1, and let's return the answer in this case. So here we will call n equals to set bit, and which bit we want to set. So let's set n and I, and let us print our answer, which is going to be n in this case. Okay, so I want to set the first bit of 5. So the first bit of 5 was 0, and after setting it, the answer is 7. So clearly you can see we are able to set this particular bit. So in the next lecture we will talk about more bitwise operations. See you guys in the next video.